Okay. Well, welcome to our June chat seminar, which we are running, which we've been running monthly since the end of last year, owing to the pandemic. Before we begin the seminar, I just want to announce the winner of the CHACS 2021 Morris Prize, and I'm delighted to announce that Professor Ernst Homburg, who recently retired from the University of Maastricht, has been awarded the prize for his work on the history of the chemical industry. For recent awards, we've had the prize lecture and the award at the International Congress for History of Chemistry, which was due to be in Vilnius, but that's obviously been cancelled, and so we're currently discussing how to do it for this particular round in such a way that if we organise an event, there's some reasonable likelihood that the event will actually happen. So we'll just keep watch on CHAC's publicity to see what we eventually come up with. Moving on to the seminar, it gives me great pleasure to welcome Robert Budd from the Science Museum for this month's seminar. He will talk for about 25-30 minutes, and then we will have a Q&A for about 30 minutes. If you're watching this on Zoom, do type the questions into the chat box, and I will invite you to ask the question personally in order. If you're watching on YouTube, I'm afraid to say that I don't have access to the YouTube chat box. One of my colleagues does. So if you type the question in there, then I will. That'll be relayed to me, and I'll be able to ask that question on your behalf. So, it's a great pleasure to introduce Robert Budd, who worked at the Science Museum in London from the late 1970s. In the course of that career, held 2 keeperships, and is now emeritus keeper at the museum. He's written widely on 19th and 20th century chemistry, and today is going to talk about coal, chemistry, and employment. Robert.
Thank you very much, Frank. It's a particular pleasure to talk to CHAC today. I hope there'll be many people amongst the audience for whom the story of coal and talking about coal will bring back some of their early education, and indeed some of the talk about the wonders of coal, which they heard as they were becoming chemists. Because the story I'm telling created the framework for thinking about this generically British mining product. You will remember that before World War I, British industry rotated around 4 great industries: cotton, iron and steel, shipbuilding, and underneath them all was coal. Employment peaked just before the industry peaked just before World War I, and of course during the war, employment reached 1.2 million people. Following the First World War, of course, oil came in, automobiles came in, ships came in, and we'll talk about that, trains. On the one, so competed in the home market, and on the other hand, export markets collapsed. Before the First World War, Italy, for instance, had been a major export market. No longer did the Italians buy British coal. On the one hand, they were producing much more energy from hydroelectricity, and on the other hand, under Mussolini, they increasingly had close relations with the Germans. So you can see the number of people working in the coal industry collapses between the wars from about 1.2 million down to about 700,000. So 500,000 jobs are lost. And of course, this is not 500,000 across the UK. This is 500,000 in a few major coal fields in South Wales, in the northeast of England, and in the coal fields of Scotland. The result was catastrophe. This is a quotation from a speech given by the chairman of the largest coal company. So he's an industrialist, a capitalist. And he gives a talk in July 1936 about the hardship of the coal miner. The South Wales coal field possesses some of the richest coal seams in the world, producing coals with the highest thermal value. It has contributed largely to the wealth of this country and has built up a population which, in addition to being skilled in the art of coal getting, is hardworking, intelligent, and loyal, and which can provide personnel for industrial undertakings equal to any to be found in any other industrial districts of the country. Adverse circumstances over which the South Wales coal industry has no control whatsoever threaten its very existence, and as a result have condemned a large part of its virile population to the demoralizing influence of unemployment. I don't need to show this audience the misery of those areas where there was 30 and 40% unemployment to which he was referring. I will remind you that the national strike of 1926 began with a strike among coal miners. I also should remind you that this was not a problem which only coal miners and the coal industry was aware of. This was a national shift of the first order. Here is an extract from an article of 1934, Science in the Coal Industry. It seems obvious that oil, petrol, gas, and electricity are taking the place of the burning of raw coal, and this will mean a saving in the amount of coal used. Though it is too soon to say how far the coal miners will suffer by this more economical use of coal. One other point seems fairly conclusive, and that is that the use of raw coal for domestic consumption will gradually decrease. Today, the housewife much prefers to use gas for cooking and eating. And however much we may like the coal fire, we have to acknowledge that only 1/5 of the heat contained in the coal is utilized in this form, and the rest finds its way into the atmosphere, which it pollutes, with resultant injury not only to our vegetation, but also to our clothes and our buildings. Moreover, we are losing by the burning of coal in its raw state valuable tars, oils, and other byproducts, which are of great commercial value. All right, so there is a sense, and I give you the example of shifts, shifting from 88% driven by coal in 1914 to only 53% in 1933. Before we talk more about coal, I want to remind you that not all coal is the same. And being a former museum curator, I want to show you some objects. So I'm going to stop share and show you some things. To an audience who 50 years ago would have lived with the stuff and nowadays may say, oh, I haven't seen that for a long time. This is bituminous coal. Bituminous coal is typically from the northeast of England, typically about 70–80% carbon, burns with a flame and smoke. Then, and by contrast, we have anthracite, much more shiny. It's almost pure graphite, 90% carbon. You can see it glistening. Burns with almost no smoke and not much flame. So its use is quite different. And this will become important in the rest of the presentation. While we're doing my show and tell, I want to show you two other artificial coals, which will come up importantly in this presentation. This material, which is amorphous, is coalite. This is coal heated, the result of heating coal in a confined space to about 650 degrees centigrade, not the 900 degrees centigrade used for making ordinary gas. And it burns with almost no smoke, but at a flame. And finally, another smokeless fuel. This is called furnacite. It's the result of research at a coal company of before the war called Powell Dufresne, whose chairman I quoted earlier. It's a South Wales company which had become the largest coal company in the country through a process of amalgamation, characterized by these two stripes. It's made by heating anthracite, a mixture of anthracite and pitch, and removing much of the hydrogen and other materials so that you get pretty pure carbon. Right. So not all coal is the same. There's a quotation I've got here, which is a rather nice one, complaining from the Scottish National Development Council about 1936. Electricity heats, gas heats and ventilates, but a real fire warms, ventilates, and entertains. Without doubt, the semi-coke fire also warms and ventilates. And there is evidence indeed that for the consumption of a given weight of fuel, it warms a room more effectively than does coal. Yet it seems to lack much of the liveliness and cheerfulness that all classes prefer. So there's a fight to keep the coal fire around which the families gather, but it's a fight the coal industry is losing in the interwar years. And one reason that many people want it to lose is pollution. You will remember, some of you who are older, that all our buildings from our youths were black. When the Fuel Research Board was set up at the end of the First World War, it had two objectives. One was to find new ways of getting coal. The other was to stop this pollution, the blackness, which was a curse of Britain. You may remember that bronchitis was called the British disease. So what was going to be the solution to all these problems? The solution promoted was rationalization. And rationalization was a combination of scientific research, of standardization, of scientific management, integration, better organization of companies. And you will recall as well an approach to culture in general, linked by Sombart and Weber to Enlightenment and Protestantism. The word itself came from Germany at the end of the First World War, where the economic problems were, of course, even greater than in Britain. So combine scientific research with organizational improvement, efficiency, and cultural change. The prophet of rationalization in this country was Alfred Mond, a founder of ICI, originally a politician, hadn't wanted, his father Ludwig Mond, of course, had been the founder of the Bonner Mond Company, but Alfred had wanted to go into politics. He's father of the Mond-Turner talks, which was going to improve industrial relations. But his, the man who was supposed to be the first head of ICI had to leave quickly due to scandal, and Alfred Mond takes over. He's also, I should say, a coal mine owner. And Alfred Mond sees ICI, the new cartel, rational organization powered by research, established in 1926, as the quintessence of rationalization. And meanwhile, the coal industry itself is rationalized through the formulation of conglomerates. Rather than thousands of small companies, you get conglomerates, and particularly the company Powell Dufresne, which will come up later. And what do the rationalizers say? The rationalizers do not say, let's abandon the coal mines. Rather, they say, let us find new uses. Richie Calder, a sports journalist who sees science as a new avenue for his talents, becomes the science correspondent of the Daily Herald, writes a book made out of his articles called Birth of the Future. And he described, in 1934, and he describes a vision. Suppose we planned the city of coal. We built the house out of coal. Even the windows were glazed from coal. Of course, perspex. We furnished them with furniture made from coal, plastics. We heated them with coal. We lit them with coal. We peopled the city with men and women clothed from coal, who ate coal and drank coal. And the women were fragrant with exotic perfumes of coal. Its broad thoroughfares came from coal, and the teeming traffic which traversed them. The aeroplanes which zoomed overhead at fantastic speeds were propelled by coal. And as we sat gazing into the black heart of a lump of Mitchell Maine, as though it was a clairvoyant crystal, he, a highly responsible chemist, was seeing as a city, not as I was, a fight of imagination, but as a metropolis of chemical formulae. So the transformation of coal is not only a vision of, not just a vision of rationalization, but also of chemistry. And it's driven by the fact that the market, the traditional market for coal, for burning it, to raise steam, to heat houses, was disappearing. The minister, the secretary, the Chancellor of the Duchy of Lancaster, writes memorandum, forwards a memorandum to cabinet from the Secretary for Mines. I have for some time had under consideration the general question of what may be termed the more scientific treatment and utilization of coal, including particularly such matters as low temperature carbonization, hydrogenation, and the use of pulverized coal. So we go from general finding new uses to these particular things: low temperature carbonization, hydrogenation, and pulverization. That's what's being talked about. I'll skip this. Alfred Mond writes a minute to his staff. This is a minute which appears in the ICI archives. He writes, the general policy of ICI is as follows. 1, to produce petrol and fuel oil from British coal. This is an important matter vis-a-vis the government, and cost is immaterial within reasonable limits. Cost is immaterial within reasonable limits. This is the instruction to the research department in 1929. And they also want to produce petrol from coal and or lignite in parts of the empire and to make useful things. This is the plant, the hydrogenation plant that is built. You can see it's a great engineering triumph. Essentially, it uses the same technology as ammonia synthesis, except that it combines hydrogen with coal tar, or we'll see with coal. And you can see the great reactor, one on top of another. It is described as a great achievement of chemistry. You can see it's a great achievement of engineering. Here's an example of a newspaper cutting. Oil from coal. It is the achievement of the chemist. In the public eye and in the chemist's eye. I should say that while the process that's been developed is a German invented process, the Bergius process. However, ICI is the first company in the world to convert bituminous coal into oil. The Germans are developing lignite, which has a lot more hydrogen and already tar in it. So it's a lot closer to oil than coal, than bituminous coal is. Now, I raised the question about what it was that was being converted into oil. And I said coal, tar, coal. This brings us to the second part of the conversation argument. Coalite. In 1904, the Syrian inventor, electrical engineer Thomas Parker, develops a way of low temperature heating of coal inside retorts which squash the remaining coalite to make this amorphous material which will burn without smoke. The company goes bust and is taken over by a remarkable aircraft engineer, Thomas Bristow, who is approached first as a consultant for the company and then becomes managing director in 1928. Whiston Alfred Bristow, sorry. And Colonel Bristow, he got the title colonel because he was developing magnetos for the Air Force during World War I and wanted a military title. He was never a soldier. He sees his process, his company, as a high-tech company. The kind of description is just like a high-tech company today. This is from his annual report in about 1933. We have for the past 2 years been engaged in the construction of very large works, which did not reach the earning stage last year, and therefore more than half our profit earning capacity was idle. As our operations expand, as new plant and processes are brought into operation, we must simultaneously carry out a great deal of research and experimental work. So this is not an old-fashioned company which can churn out profits. This is a company which is going to churn out new products. It's going to heat coal, not in the typical way at 950, but at 650. And as a byproduct, it produces oil, creosote really, creosote which the Royal Air Force can burn. And from 1932, 12 squadrons are using his high octane. It's about 65 octane, so it's not high octane by our standards. They hire research chemists in London, though they're based in Derbyshire. But they also produce a creosote which can be, their creosote which they produce can be used as input for ICI's hydrogenation plant. So here you see, and I'm not going to run this, you can see the way in which they're refining some of their creosote into a diesel oil, some of it into a petrol, which they sell through Carlos Capel, which is the company which gives the name petrol, and they sell it as choline. But the most important thing is that they will sell it to ICI. And so you see an integration of these two processes to make a new industry. And rather that they would want to spread this not only to Derbyshire, where it starts, but to Scotland and South Wales. In Scotland, as late as the 1938 Empire Exhibition in Glasgow, the centre of the exhibition, unfortunately, all I've got is a picture of the side, but the centre of it is a large coal oil plant burning creosote from a coalite plant. South Wales has got a problem that its largest product is anthracite, and anthracite cannot be made cannot be hydrogenated. There's a lot of effort to convert anthracite into oil using the Fischer-Tropsch process, which, as you will remember from school days, you pass steam over coal, and you get carbon monoxide and hydrogen, which you can then re-synthesize into oil catalytically. They also have another process for making bituminous coal into smokeless fuel using a local South Wales process. But the main effort in South Wales is this Fischer-Tropsch process. And this is picked up particularly by Powell Dufresne, who hire a top-flight Cambridge-trained chemist who had been worked at ICI, was the job manager at the Billingham Oil Works. In 1933, is hired by Powell Dufresne at a salary of £800, rising to £1,100, which is considerably more than a professor at the time. He builds a new research laboratory for Powell Dufresne. His brother, incidentally, is Elwyn Jones, who I was pleased to see laid the foundation stone for the Kew National Archives. In Kew, you'll see this says this National Archives building is laid by Elwyn Jones. And Idris Jones would go on to found research at National Coal Board after the war. This is a picture of the research laboratory he founds at Powell Dufresne. And the main work is to develop the Fischer-Tropsch process. Fischer-Tropsch actually doesn't happen, but it does feature in a novel by Hammond Innes, All Roads Lead to Friday, published in 1939. There is an attempt to build a coalite plant there using bituminous coal, but by the time it's built, there's a great shortage of coal miners and indeed a great shortage of coal because World War II has started. By the late 1930s, the government is concerned with the threat of war and the threat of bombing tankers. and there's an investigation about whether coal hydrogenation be developed in order to make it unnecessary to import oil. However, it's very quickly worked out that it's a lot easier for the Germans to bomb 1 or 2 or 3 coal oil plants than it is for them to destroy hundreds of tankers crossing the Atlantic. So from a defense point of view, coal oil makes no sense, though it will be used. The ICI plant is used to make high octane fuel during war, which will enable the Spitfire to shoot down V1 bombers. But basically, the argument that defense is the reason for a legitimate reason for hydrogenation and for this processing of coal is wrong. The main argument is to maintain jobs for coal miners. You see, for instance, here, that was the Labour's plan for coal. The Labour Party, of course, being closely associated with the miners, is very keen on making oil from coal. Conclusion. Science and research were proposed, and particularly chemistry, as the solutions to the woes of the coal industry, without going backwards. The kind of stories about coal that we were taught is an outgrowth of that vision. Coal hydrogenation had strictly limited use in the 30s, though it symbolized the potential of chemistry. There was only ever one plant built. And such potential was as much part of the identity of the goals of science as strategy for the coal industry. This was the largest industrial research project of the interwar years, by far, and the highest profile. Nonetheless, the problems of the coal industry were temporarily resolved by World War II rather than hydrogenation. After the war, Coalite became a major company. In 1988, had sales of £615 million and 7,000 employees. But of course, in the era of North Sea gas, its days are numbered. World War II coal liquefaction is only systematically pursued in South Africa. And much of the rhetoric, idealism, and technology is transferred to atomic research and development. A lot of the rhetoric you will see in atomic research and development is pioneered in the talk about coal liquefaction. And chemists continue to talk of coal as too valuable simply to burn. A descendant expense, which was a descendant of experience, it was too expensive to use as a fuel. Thank you.
Thank you, Robert. That was absolutely fascinating. We only got one question on the chat box, but I will exercise my usual chairman's prerogative and ask the first question while others add to the chat box. Could you say something about the development of chemical engineering in this context, in this country? Because it's very noticeable that in at least a couple of instances, the engineers involved came from other engineering specialties, electrical engineering, I noticed particularly. So is there a story to be told about chemical engineering and how that arose in this particular context of coal?
Well, it ought to have been. In America, chemical engineering arises in the context of petroleum.
Well, could you de-screen?
Oh, yes. In America, chemical engineering arose out of the challenges of developing petroleum engineering. ICI was in fact late in developing chemical engineering compared to the American companies. It wasn't a pioneer in this period of chemical engineering. After the war, it will be. But in this period, ICI takes its lead, its model from the German companies, which, as we know, were also not leaders in chemical engineering. They had a model of using engineers on the one hand and chemists on the other, in part because they were used to dealing with solids, and chemical engineering was particularly powerful in dealing with gases and liquids. And many of the problems which ICI was used to dealing with were solids. In fact, the coal hydrogenation plant, one of the reasons it worked so well with coalite is that it could take in a liquid, the creosote byproduct from coalite, and meant that the plant could be shut down very quickly if there was a bomb, if there was a threat of bombing.
Right.
Whereas if there were coal furnaces, that was much slower to shut down. So the answer is, I think, that ICI was slow in chemical engineering, and this was a learning process about how it introduced ICI to dealing with oil. Interestingly, it was built at Billingham, and ICI developed its post-war petrochemical plants at Wilton, a few miles away. So the plant itself was only knocked, although it stopped producing in 1958, is only knocked down in the late 80s, about 30 years later. And I noticed that Peter Morris is online. Peter, I think at that time, was responsible for extracting what few bits there were of it.
Right. Okay, so thank you. Andrew Petrika, would you like to demute yourself and ask a question?
Yeah.
Working on it. Hello.
Hi, Andrew.
Hi. So my question is, Robert, in looking at rationalization, have you seen anything on rationalization in a continent, say in France or Germany?
Yeah. The word rationalization is coined by Emil Rathenau, who was a philosopher. Rathenau was the son of the founder of AEG. He became the very successful organizer of the German munitions industry during World War I, became a liberal philosophical foreign minister in the aftermath of it, and is assassinated. I don't know, but it'd be interesting to find out if there were any links between Rathenau and Mond. Mond himself was born in Germany and spoke English always with a German accent. They had actually rather similar backgrounds, Mond and Rathenau. But it is, and also in America, the definition I gave you there of rationalization came from an American source. So it is a global, and there is a book, one of the Tensions of Europe volumes deals with very specifically with rationalization across Europe. So you will find the Batter Shoe Company in Czechoslovakia. Okay. So yes, it was international.
Okay, Alan Jones, can you demute yourself?
Hi, yes, hello. I was wondering about what the price of oil or petroleum from coal, how that compared with the usual sources.
It was much more. One of the problems of oil from coal is that it was much more expensive. There was a problem with dealing with, it's a question of how you do the accounting, one of the things. The coal that was used, particularly for the Fischer-Tropsch division, would have been very small bits, which weren't much used for anything else. And so you could, rather than working out the cost of the coal per ton, if you said the coal had no value, then you could come up with a reasonable cost. But basically, making synthetic oil was much more expensive than importing it from the Persian Gulf, where BP had built a big refinery, or from America.
Yeah, thanks. I kind of guessed it was probably depending on how you did the accounting.
It was
all the cost of the research was that,
the cost of the biggest economy, you would say, is in unemployed coal mine, paying national insurance to coal miners, and of course the political threat from coal miners from unemployed. There had been real scare of a revolution in 1926,
yeah,
precipitated by unemployed coal miners. It was a political move, and you didn't know whether this would. The Germans, of course, came to build many Bergier's plants, but it was always much more expensive, and and proved again so in the 1970s when there were attempts to build again.
Yeah, thanks.
Thank you. Alexander Eggerhofer.
Yes, very interesting talk. Thank you very much. So I was curious about how ICI collaborated with other companies abroad, say in Germany or in France or in the US, in building their coal liquefaction capabilities.
They were members of there was Bergius started developing his process by himself, and in the early 1920s saw that he couldn't fund it himself, and a Bergius consortium, which was dominated by Germany, but also had Standard Oil in America as members and ICI. So there was a consortium of shared knowledge, and ICI worked very closely with them, but the Germans were focusing on converting lignite, soft coal, brown coal,
right,
and the British, not having any brown coal, focused on bituminous coal. The Americans were using it mostly as a way of developing ways of converting low-grade petroleum tars, heavy petroleum, into petrol, into gasoline. The technologies were similar, but there was very close. In the Fischer-Tropsch process, there was an interesting case where the British wanted to buy Fischer-Tropsch, and the Germans were a bit nervous about it. On the one hand, they wanted the foreign currency. On the other hand, they didn't want the British to, in the late 30s, to develop methods of indigenous manufacture. So they charged the nominal value of the Reichsmark, which was not the same as the street value, so to speak. And there was a lot of discussion about what value of Reichsmark were being calculated, and also how full the information was. On the other hand, there were a lot of German refugees. So, for instance, the professor of coal technology at Munich fled to Britain and became a consultant to the British. So there was a lot of technical transfer to people, as well as formal consortia. And that has never been studied, as the way in which German coal technology came to Britain through the refugees.
Okay, thank you. Caroline Coble. Caroline.
Sorry, just unmuting myself. Yes, fascinating talk. Thanks, Robert. As you might well know, I'm fascinated by the chemistry of coal, having studied a lot of its applications in various things, including in food. But the thing I wanted to, this is a comment and not a question. Are you aware of the land settlement facilities that were made for unemployed miners in the 30s and 40s? Because we've got some near us. Yes. And a local historian called Bill Martin has done a fascinating project on those miners that were sort of relocated all around the country and given 5 acres of land to grow their own food.
I didn't know about that. One thing I didn't talk about was were the regional development authorities set up, and how both Scotland and Wales regional development authorities were very keen in developing this technology and had problems with ICI. The Monmouthshire Development Authority wants to develop methods of making oil out of coal for South Wales and buying a plant. But it's, you could go, one could get lost in the history of the coal industry. One of the curious, and the consequence of the coal miners, curiously, the history of the coal industry, the official history of the coal industry hardly deals with these attempts to revolutionize coal by turning it into something else completely. So that, but I think that you're quite right to point to the great political challenge of unemployed coal miners, of these 700,000 people.
I mean, presumably that plays into the thesis you were sort of arguing about revolution. If you distribute your miners around the country in sort of low population levels, you get rid of a lot of the problem.
Absolutely. But they would feed the Communist Party.
Many comments in Chichester when I last looked, I have to say. Jim Bennett. Jim.
Thanks, Frank. Hi, Robert. I want to take you back to your very first sentence. Maybe it was just a throwaway remark and you didn't, it just slipped out, but you can see what you say. I mean, that was to say where you said that coal was in some sense generically British. That's to say there was something characteristically British about it. And it's, you know, the questioning has been nudging you towards taking a more comparative international viewpoint on various questions. And, you know, you yourself referred to the German, we know about the Ruhr Valley, and you know, we've read Zola, and you know, so what is it what did you mean by that?
I think that
is it just that it looks like that from here, or is there something deeper in your characteristic that you wanted to bring out?
It's talked about at this time as our national fuel. And before the First World War, the British had 50% of all the coal exports in the world. The British coal industry was much bigger than the French, and it was much more important to the British identity than coal was to the French identity. To the Germans, that's a very interesting question, and I leave that to people who know more about Germany than I do, about the importance of coal to German identity. But I would say that there are parallels today with coal and the significance of Polish identity, as far as I can see. But certainly to the British at this time, and we can see at the time of the coal strikes, how deeply entrenched coal industry was to the Northeast and across the country. Closing the coal industry was not just a question of some more unemployment. It was a challenge to the regional identities. And I think that has to be taken into account when we look at the amount of effort put into this coal liquefaction.
Bernadette, do you mind if I just skip over you and come back to you? Because I think Robert Fox's question plays to what Robert's just been talking about. Is that okay?
Yeah, but I have just a few minutes.
Okay, Robert Fox.
Robert, he's got his mute on. He's muted.
There I am. Yeah. I was intrigued by your Labour Party pamphlet,
yes,
and I wondered to what extent, thinking of that sort of area of the political spectrum, I wondered how far union leaders were actually involved in the fashioning of policy, and the sort of corollary of that and the thought behind it. I mean, as somebody brought up in South Yorkshire, I feel quite sensitive to NUM matters and so on. And I'm very sensitive of the deep splits in the union movement at the time of the miners' strike, for example. But I just wonder to what extent union leaders really did figure in the discussions.
One of the things is that this could bring not only unions and management together. So the papers I found that I quoted, showed that speech by the chairman of Powell Dufresne. That was in the papers of a union leader in Hull, as it happens. It was an area where union leaders, management could come together. And as you will remember, the strike of 926, the generals, had been very divisive. I can't remember who it was who said that the union leaders were the most stupid men he'd ever met, except for the management of the coal companies. And they had really hated each other. This was a way to bring them all together. And indeed, that was the Mond approach. The Mond-Turner talks have been very specifically about Mond as sort of representative of the management talking to Turner, who was the head of the TUC. So technology, or chemistry specifically, would heal the nation. And of course, we've got the Soviet Union over the way. If you talk about international comparisons, in the background is the Soviet Union and what had happened in 1917.
It's a very interesting gloss, Robert. Thank you very much.
So, Bernadette, sorry about that.
Yes, hi, Robert. Yeah, my question is more concerned with the identity of coal than the British or the miners. I was really glad to see that even in the British context of the Industrial Revolution and later, coal was much more than just a fuel to burn. And I wonder whether the chemistry of coal that you mentioned, especially with the Fischer-Tropsch process, could be seen as a pathway leading to the chemistry of carbon fiber and nanotechnology in the late 20th century.
No.
No.
But I think that in a curious way, that I've been to the carbon fiber people. I've looked at carbon fiber history because I was interested in Farnborough and I acquired an oven. And that got its technology from aviation and aeronautics technology. The coal was really was abandoned as an old-fashioned, but it had been this wonderful chemistry, this wonderful mixture of stuff, was a way of coping with the declining of burning, is that you emphasize more and more the chemical richness and wonders of coal as you stop burning it, because nobody wanted it burnt. And the first defense is to say, well, we don't need to burn it anyway because we can use it for so many other things. In a way, I think the carbon, I saw no link. The people involved in carbon fiber were in a quite different part of the country, and it was in Farnborough. And I suppose there was one place, and maybe what you would say, that where carbon fiber overlapped with the coal industry. It did overlap, which was Courtauld, but it was really fiber technology. There's a separate process, I think, which is to do with cotton. If you asked me what it had to do, what carbon fiber and nano had to do with cotton and textiles, I would say probably quite a lot. Attempt to rescue the cotton industry, which was one of the other major industries of the country, which also was collapsing in parallel. And there's a link between the cotton industry with crystallography, we know, and nanotechnology. And I think actually cotton, and I should say, by the way, that carbon fiber is made by burning a textile, acrylonitrile. So I think actually it's got to do with cotton, which is another British obsession, but a different one.
So it's always British.
Oh yeah. If I could just follow up on that, excuse me, Bob J. Rosalind Franklin was directed to do her PhD at the Coal Utilisation Research Association on basically holes in coal. And she then went to do a postdoc in Paris under Jacques Mering. And it is claimed in various of her biographies that some of the work she did there, particularly in Paris, but also in Baron's Court, where the unlikely location of the research association's laboratory was, did contribute to laying the foundations of carbon fiber technology. Yeah. But you're doubtful from what he's saying.
But and Mary Stopes, you could say Mary Stopes, the contraceptive woman founder in this country, was also a coal chemist. I think part of the story that coal chemistry was a very dominant context for doing chemistry and doing science in general. So it'd be an interesting challenge to take nanotechnology and back to coal and cotton. Unexpected.
Rob.
Just an observation, really, Frank. I noticed that the plant at Billingham was opened by Ramsay MacDonald.
Yes.
Who was, of course, the Labour Prime Minister at the time.
No, he wasn't Labour Prime Minister.
Oh, was he not? Right.
He had been Labour Prime Minister at the time when the plant was approved.
Right.
By 1935, when the plant is opened, Baldwin is Prime Minister. But as a courtesy to Ramsay MacDonald, who had driven it through, Ramsay MacDonald is invited to open it. But I think that it also indicates Ramsay MacDonald's close association with the, as you say, with the union movement. And that Ramsay MacDonald and the Labour Party were very closely associated with that plant. And there is, but the local church service has a special, there's a special service in gratitude to coal liquefaction.
Right.
Because
when
it's the mind.
When you say that Ramsay MacDonald had driven it through, had he then pushed and provided ICI with lots of funding to make it work?
Yeah, it's also got to do with the tax that oil produced through coal would not be subject to the same tax as petrol.
Right, okay.
That's
So
a nice one. Bearing in mind your thesis. I mean, also one should remember that Ramsay MacDonald, when he first came to London in the 1890s, intended to be a geologist at the Royal School of Mines rather than Labour Party politician. Then he met his radical wife, and the rest is history, so to speak. So one final question, I think, from Guthrie. Would you mute yourself?
Yeah, sorry, it was more a comment in passing. If you're looking for obviously links between fibre and clothing, textile industry and coal, there's the dyes, but whether that actually, so that does make me wonder, how did the dyes carry on? Is there much about the dyes in the early 20th century? They kind of, I know it was fairly busy, but.
Yeah, no, ICI, remember, I mean, there's Mond, head of ICI, and also owning a coal mine. The great challenge actually is to wean, after the war, is to wean ICI off coal. ICI is not keen to switch to petrochemical feedstock. And curiously, the coal, Bevan funds a small company, Petrochemical Limited in Manchester, which becomes the Shell Carrington oil refinery, a Shell petrochemical plant, really to taunt ICI into going into petrochemical feedstocks, because ICI is very associated with the coal dyes complex. It knows coal, it doesn't know oil, and it doesn't want to go into competition. It's very specific in the correspondence. It doesn't want to go into competition with its suppliers, with the coal tar manufacturers. But it is a coal is part of the chemical industry in Europe, as in Germany. And ICI is very close to the German chemical companies. There was, I noticed that even when I visited BASF in 1981, how close BASF was. We talked about ammonia manufacturer. And although ICI used a slightly different process, they were very happy to talk to me about our friends at ICI. This was a world of cartels where the market had been divided up between different companies and different countries, so to speak, territories. The Germans had Europe, the British had the Empire, the Americans had America. And that broke down, of course, after the war. But at this time, that's how it's run.
Okay,
thank you.
Thank you. The idea Britain had the Empire, America had America. I think it's a nice place to draw.
Of course, the American market was much bigger than the British Empire market. But
of course, yeah. Okay, so well, many thanks, Robert. Shaq's decided to run 2 more online seminars this year, probably in September and November, which will be advertised in normal ways. These seminars don't happen by magic pressing of the button. There's actually quite a large team behind delivering them, which in this case was also Anna Simmons, Rob Johnson, Becky Martin, Joe Hedison, and Carolyn Cobbold. But last but no means least, Robert Bradford delivering a really fascinating talk, which really raised some really interesting issues about the nature of employment and nature of markets and so on throughout not only Britain but throughout the world. So thank you, Robert, and have a good summer, everyone.
Thank you for being such an interesting audience.